This is going to be my demo for target 3A. The target is that I can simplify Boolean expressions through algebraic manipulations using or including De Morgan's theorem. We'll start with De Morgan's theorem. First, I want to break up this large bar. And I'll be keeping the bars over it to make it easier instead of so I'm not like flip-flopping the signs and operations multiple times. I can just do it all at once. So since there's two bars over, A with two bars on top equals A. So I'm keeping that the same. I'm also going to be keeping the operations the same instead of flip-flopping it from addition to multiplication and back to addition. And this is a quantity. And then for A, I forgot another bar. Okay, so A is going to be kept the same. And then B is going to be knotted. Now I want to FOIL. All right. And then A ANDed with itself is going to be 1, right? I have my rules right here. A ANDed with itself, A ANDed with itself is going to be A. So it's going to be A and B prime plus, and then here we have B ANDed with its complement, which if we look is going to equal 0. So this whole thing is going to be 0. And then we can simplify this further, just rewriting it without the 0. And that is going to be our final answer. Moving on to rule number 10, absorption. So like we stated earlier, A times its complement is going to equal 0. And then we have these two expressions. And we can factor out an A from both of them. So here we have A times the quantity, or ANDed with B plus B. And here we can look at our properties. B plus B prime equals 1. So this is going to equal 1. And our final answer is just A. Moving on to the simplification property. So first, we can recognize that A and C are present in both of these quantities. So I'm just going to factor out an A and C. That leaves me with B or B prime plus A. And then using the same rule that we've used, B plus B prime, let me just double check, is going to be 1. So we can just rearrange it to match the property. And here we see that we can just rewrite this as A plus C. And that's going to be our simplified version. And then moving on to the demo for target 4A, that I can write a truth table with verbal expression and vice versa. So the verbal expression is going to be, for my next car, I'm looking for a car that checks off at least 2 of my boxes. Either fuel efficient or SUV or remote start. And here I have my inputs laid out and my output. So I have A as fuel efficient, B as SUV, and C as remote start. And my output is going to be U. So since there are 3 inputs, I'm going to have 8 rows. Awesome. And then I'm just following the pattern. So my most significant bit is going to be alternating by 4, and then by 2, and then by 1. And then I want it to satisfy at least 2 of my conditions. So if none of my conditions are met, I'm not getting that car. If one of them is met, I'm not getting that car. Same for here. Here I would get this car. I wouldn't get this one. I would get this one. And of course I'd get it if it checks off all my boxes. And then the algebraic expression will be that U equals A plus B plus C, because these are going to be ors and not ands. Thank you.